All right, y'all. So the rest of 6.8 deals with finding maximums and minimums still. So I'm going to go to Math Lab so that we can see the graphs when we're working these problems. So let me get Math Lab up. All right, y'all, I'm going to make that graph a little larger for us. So a relative maximum or minimum is still terminology talking about the maximum and minimum points. Okay, so maximums will be the peaks or the tops of them, to where a minimum will be like a valley. Okay, so let me let one in real quick. So on this one, they want to know if they have a relative maximum or minimum. Well, that's a peak, so that's going to be a relative maximum. So you're going to click that and then have it check your answer. So now instead of using that vertex point like we did in 7.5, they want to know what the relative maximum is and where it occurs at. So they're giving me the point 4.5, comma 8.25. So the x value is the 4.5. So you would put that in for the x value. And then remember, the y value always gives us the min or max value of these, okay? Which will be, on our case, 8.25. All right, y'all, then we check our answer. Now, they're going to want to know if this is increasing on what intervals. So let's see. So y'all, we've done enough increasing and decreasing. So let me ask y'all this. On increasing, would y'all pick A, B, C, or D? Remember, this left side of that graph is increasing. So it's coming in from the left way out here, because remember, that line goes forever down. So it comes in from the left from negative infinity, and it's increasing on the graph as I go over, and it stops about right here at that x value, which was 4.5. So we want a negative infinity to
That'd be C.
So that'd be C. So remember, we're still just focusing on the x values when we do the increase and decreasing, y'all. And then remember, the arrow is not telling me the direction. The arrow just means that this graph keeps going down, okay? All right, so knowing that, on what interval is this function decreasing? So let's see, we're right about here on that x-axis where my cursor is. And if you notice, that x value is 4.5. So at 4.5, it starts going downhill as I head off to the right. And remember, as we head to the right, we're heading towards our positive infinity. So y'all, we need, what's that, A, B, C, or D? What's got 4.5 to infinity?
D.
So D is in delta. Good job. And then you would check that answer and be done. Now, let me make this graph a little larger. So y'all, this graph, I'm going to bring it up just a little bit. This graph has a relative maximum, which is where the little peak is, but it's also going to have a relative minimum where that little valley is. So sometimes a graph can have what we call a relative max, which is the mountaintops, and a relative minimum, which is our valleys. So on this one, they want to know the relative maximum. Well, y'all, that's that little mountaintop here on the left side of the graph that's got that point. Looks like they're giving us what, -3, -1. So that's the point at the top of the little peak. So that relative maximum is the y value of -1. and that occurs at my x value of a -3. So it's still doing sort of like vertex stuff. But they're wanting us to find it for the different peaks and valleys on the graph. So y'all, how about y'all try this one? Your relative minima is blank at x equals blank. What y'all putting in them boxes?
-9, what?
So -9, because that's the y value, and then that happens at the x of 1. So these are pretty much giving you the points. You just got to decipher which one's the minimum or maximum value, and then which one's the x value on those, okay? So check that. That's all you're doing on that. And then it's going to have increasing and decreasing. So let's see. So increasing, there's two parts of this graph going uphill. My first section is going uphill, and the third section of this graph is going uphill. So A, B, C, or D, let's figure it out. So the first section is coming in from the left, from -infinity, as we're going down the x-axis, and we hit that -3. So we know we need a -infinity, -3, so that's A and D. So then we come down the x-axis to the second section where it's increasing. And that's starting at that 1 on the x-axis. And from 1, it's cruising to the right towards positive infinity. All right, y'all, so we need -infinity to -3, and then from 1 to positive infinity. So y'all, that looks like D. So we pick D, check that answer, and then we continue on. So if the first and third section were increasing, the second section in the middle is going to be decreasing. So y'all, A, B, C, or D will be my interval for decreasing. Which one y'all picking?
Looks like B.
So what's that? -3 to 1? Perfect. All right, so one more to make, oh, okay, this graph, I'll make it a little larger. Now this one's got A, B, C, D answers on it. So we just got to pick out our relative maximum and our relative minimum. So I'm going to start with the relative maximum, which is right on the y-axis at the y value of 1. So that has a y value of 1 and an x value of 0. So my maximum is +1 at x equals 0. So B and D are two choices so far. A and C are both wrong. So now we look at our minimum. My minimum is the point where it's in the valley, and that y value is -3, and it happens at the x value of 2. So let's see, between B and D, well, B said there wasn't a relative minimum, and we definitely got a relative minimum. So I'm going down to D, and y'all, that has the y value -3 at the x value of 2. So we're going to click that, check that answer. Now, I don't think this one makes us do increase, and this one just had the maximum and minimum. So y'all, let me write this one down so I can do it by hand. We're going to find g of -4, g of 1, and g of 8. They're giving me g of x equals, and let's see, I got two equations. I'm going to use the x plus 6 equation for any x's that are less than or equal to 1. I'm going to use the 3 minus x equation for any x's that are greater than 1. So now Monday, when y'all did these, all you had to do was pick out which equation you would use. But now they actually want us to find those values. So we're going to have to pick which equation we're going to use, plug that number into it, and see what we get. So we'll go work all 3 of these by hand, and then we'll come in and put our answers. So y'all, I'm going to start with g of -4. So the first question you got to ask yourself, is that -4 less than or equal to 1, or is -4 greater than 1? Well, y'all, -4 is definitely going to be less than 1, so we got to use the first equation. So using that first equation, we're going to put a -4 in for that x. So we're going to have -4 plus 6. And y'all, 6 and -4 give me what? A +2. All right, then they want me to find g of 1. So I guess since I picked the first equation for -4, one of y'all tell me which of these 2 equations would I use for 1? Is my x less than or equal to 1, or is my x greater than 1? So do y'all want me to use the x plus 6 equation or the 3 minus x?
The first one?
So x plus 6, because that x is equal to 1. So that equals made this one true. So we put a 1 in for the x. We got 1 plus 6. And that's going to give us 7. All right, y'all, g of 8. Same thing. Do y'all want me to use the first equation or the second equation for that 8?
Second.
Second equation, so that's 3 minus x. So that's going to give us 3 minus 8. And that's what, a -5. So let's go put our 3 answers in, and then we got one more for this section, okay? Y'all, we said we got a 2 here, so you got to put in each answer, and then it'll click you to the next. Now, y'all, I'll tell you the biggest mistake I get on this problem is when people see that g of -4. Remember in earlier questions, earlier in the section, it said, what equation would you use? So people are putting in that x plus 6, but y'all, it ain't asking for the equation this time. It's asking for the actual values. So this one, we got what, 7, I think we said. And then g of 8, we got a -5. So remember the first 3 homework assignments, yeah, they did want those equations, but the last 2 here, they just wanted us to evaluate. So this one, what do I got? Ooh, they got 4 things this time. H of -5.
That's gonna be -2x minus 11.
Let me let one in real quick. Where's she at? Okay, H of -5, H of -1, H of 5, and then H of 9. All right, now notice this one's got 3 equations. It's -2x minus 11 for any x less than -4. It equals 5 for -4 less than or equal to my x less than 5. And then it equals x plus 7 for any x greater than or equal to 5. All right, y'all, so I got that wrote down. Let's go working. So we start out with h of -5. So I got to figure out, is -5 less than -4? Is it equal to -4 or less than 5? And then is it greater than or equal to 5? So remember, -5 is left of -4, so it means it's less than -4. So I'm going to use the first equation. which is -2 times my x of -5 minus 11. So y'all, that's going to give me a positive 10 by multiplying, and then minus my 11, which gives me a -1. So what's next? H of -1. So y'all, for -1, are y'all using the first equation, second equation, or the third equation? Is -1 less than -4?
Yes. Yeah, you're gonna use the first one because it's less than -4.
Oh, but remember, let me show y'all something. Remember on your number line, like here's your number line. Remember, here's 0, -1, -2, -3. Remember,
Oh,
the smaller I go, the further I go left, the smaller my numbers are.
oh, so it's gonna be 5 then.
Yeah, so since here's -1 and then -4 is over here, since -1's to the right of -4, it's actually greater than that -4. So it's not the first equation. So is -1 in between that -4 and a +5 over here?
Yes.
Yes, so we're going to use our second equation. But y'all look here. The second equation doesn't have a variable. So any number that fits in this interval automatically equals
5.
5. Good job, because that's like a constant line going across there, okay? All right, y'all, what was next? H of a +5. First equation, second equation, third equation.
Gonna be the third one.
The third one, because that equals, so 5 equals 5 makes that one true.
Mm-hmm.
And so that's x plus 7, which will be 5 plus 7, which looks like 12. How about h of 9?
It's gonna be the same one.
Same one, because that's bigger than 5 again. So y'all, that'll be 9 plus 7, which will give us 16. So I won't put these answers in MathLab because that was our last problem. But yeah, you would just have to put these in one by one, and then you're done with 6.8. So it's not bad finishing it. It focuses a lot more on the increase and decreasing and that fun stuff. So y'all, the last section's coming up. Now, this one has probably the most algebra in it if you like algebra. So this 5.4 deals with complex rational expressions. So really, rational means fractions. So they're going to be dealing with something about fractions now. There's one formula that we're going to show you in this section, and then we'll work problems using it. So any of y'all, if you have to take business calculus or calculus, you'll probably see this little formula again. We call this the difference quotient. And basically, we use this. It's sort of like a fancy slope formula, but I can use this when I have curved lines and lines that go uphill or downhill, not just straight lines, okay? So I can use this on any function, basically. So the difference quotient is given by the following formula. F of x plus h minus f of x all over h. This is sort of like the y2 minus y1 over the difference of the x's on the bottom. But now it can relate to functions and not just straight lines. So the steps we're going to follow, because what we're going to do, we're going to construct this and then simplify it. So here's our steps to construct and simplify. Now, they'll give us f of x. They're going to give us something like f of x equals 3x plus 2, something like that. So they're giving us f of x. It's always got an h in the bottom of the formula. So the first thing that we really got to find is what does the f of x plus h equal? So first thing, find f of x plus h by substituting x plus h into the x's of f of x. So when they give me f of x, I'm going to find f of x plus h by replacing those x's with this x plus h. Then I'm going to plug everything into this formula. So then I'm going to plug everything into the formula. Which basically is the f of x plus h and the f of x. Because remember, it's always h on the bottom. Now, when I put them into the formula, I'm going to put my f of x plus h in its own parentheses, and then my f of x in parentheses. Because when you subtract functions, your first step is to put them in parentheses. Now, at this point, I'm going to remove the parentheses. On top. But y'all make sure to distribute all right, y'all, let me let one in real quick. So make sure to distribute the subtraction through the second parentheses. Okay. Now, after I've gotten rid of my parentheses on top, I'm then going to combine like terms on the top. Now, if you have combined your like terms on top, you're going to see a lot of stuff is going to start canceling out when you combine those like terms. So after this step, the only terms left will have h's. Everything else that doesn't have an h is going to add and cancel itself out on top, okay? Only things that'll be left will have these h's in them. So then, the last step is to simplify this thing. So we're going to simplify by dividing all terms on top by the h in the bottom. Now, y'all, I might have 2 or 3 terms on top. Every single thing on top has to be divided by that h that's in the bottom. And, at that point, we're done. So the main thing on this is getting the f of x plus h. Once we got that, we're just plugging everything into our formula here, okay? Now, they're nice, and they give you the formula on every problem. So you don't have to memorize this. They'll actually give you the formula on every one of their problems. So y'all, guess what? We got 5 problems to do using the difference quotient. So let's get started on them. Some are longer than others, depends on what kind of function they're giving us. So here we go. For f of x equals 7x minus 3. They want us to construct and simplify the difference quotient. And remember, they're giving it to us f of x plus h minus f of x, and we'll put all of that over h. So y'all, here's the thing. Here's my f of x, 7x minus 3. That's what I'm going to put in for the f of x here. But what we got to find is what's f of x plus h going to be. So the first thing I'm going to do, we're going to find f of x plus h by taking this f of x equation and putting our x plus h in place of that x. So that'll give me 7 times x plus h minus my 3. All right, y'all, the only thing we can do to this is distribute that 7 through these parentheses. So I'm going to get 7 times x is 7x. 7 times h is a 7h. And then at the end is my minus 3. So y'all, guess what? We can't go any further with this because I have no more like terms. So 7x plus 7h minus 3 is now what I'm going to replace f of x plus h is, this formula. All right, so let's plug in. F of x plus h is 7x plus 7h minus 3 minus my f of x, which they gave us, 7x minus 3, and all of this we put over h. So y'all, here's my f of x plus h, and this was my f of x. So once I plugged everything into the formula, we now got to drop the parentheses on the first function, and we're going to distribute that negative through our second function. So that's going to give us a 7x plus 7h minus 3. All right, y'all. Negative times a positive makes that a negative 7x. And then this negative times a negative makes that a positive 3. All of that over my h. All right, y'all. So if you look at top, I got like terms I can combine on top. 7x will add to a negative 7x, but guess what? 7x, negative 7x, they cancel out. All right, here I got a negative 3 and a positive 3. They're like terms. But guess what? When you add a negative 3 to a positive 3, they cancel out. So remember, we said when we combine like terms on top, the only terms left will be the terms on top that contain a h. So y'all, since everything cancels out on top other than the 7h, I now have a 7h over h. So the question of the day, does this 7h over h simplify any further?
I don't think so. Unless we do the H and the H cancel out and it equals
Okay,
7.
well, you just said it. I'm going to do what you just said. I'm going to cancel out them H's. So all that's left is our
7.
7. Good job. Mm-hmm. So yeah, that was that part when I had it. Remember when we said simplify by dividing all terms by that H on the bottom. So y'all, not too bad. You just got to keep up with finding that f of x plus h. Now this was a straight line, and the slope of that line was 7. So remember, on a straight line, the slope is always the number in front of the x. The 3 is your y-intercept. So on a straight line, this proved out to be the correct answer because 7 was the slope in front of the x. All right, so let's see what number 2 was. So number 2, they're giving us f of x equals 6x plus 10. And then we're going to construct and simplify. Difference quotient. So that's f of x plus h again, minus our f of x all over our h. All right, so I'm going to move my camera down a little bit to get more writing room. So remember, the first thing I got to find, everything else is given. I got to find f of x plus h again. So we take our f of x and replace that x with our x plus h. So we'll have 6 times x plus h plus 10. All right, y'all, remember a while ago, all we could do at this point was distribute our 6 to get rid of our parentheses. So that gave me what, a 6x plus my 6h plus my 10 at the end. All right, guess what? No like terms are on this. So since we cannot simplify this any further, we're going to plug everything into our formula. So f of x plus h is now 6x plus 6h plus 10 minus my f of x, which is 6x plus 10. All of that divided by our h. All right, y'all, so looks like drop parentheses now. And when we drop parentheses, we gotta distribute our subtraction again. So the first 3 terms come out, 6x plus 6h plus 10. Negative times a positive makes that a negative 6x. Negative times a positive makes that a negative 10. All over h.
Mr. Eugene, hold on 1 second. So going back, remember when you came to that second part and you said there were no like terms, right?
Well,
did the last one have like terms?
At this point, my 6x, 6h, and 10, they don't have like terms at this point.
Right.
But now, once I put them in my parentheses and I got rid of the parentheses,
they have like terms.
I got all kinds of like terms up there, right?
Okay, I'm following. Okay, I got it. All right, go ahead.
So 6x and negative 6x, they're like terms, but what happens to them?
They cancel.
They cancel. And then what's left? Oh, that 10 and that negative 10, same thing. They're going to cancel. So all that's left on top is that 6h.
And our answer is 6.
Yeah, because at this point, my h's are going to cancel again. And I get a final answer of 6.
Okay.
We all remember that's a straight line and the slope is the number in front of the x. So since this is in slope intercept form, We got to get 6 for our answer because that's the actual slope of that thing. And that's what this is basically finding is those slopes, okay? But y'all, guess what? Every line in college algebra is not too straight, is it? We do a lot of parabolas and we do them squiggly lines. So let's play with some of those. How about a f of x equals x squared plus 3?
You want to watch, Waylon?
But I got somebody's noise. I got someone coming through. Let me.
I'm sorry.
Okay, you're good now. All right, so same thing, construct and simplify the difference quotient, and we're given f of x plus h minus f of x all over my h. So first, we're going to find f of x plus h again. So put an x plus h in place of that x. So you're going to have x plus h squared plus 3. And y'all guess what? X plus h squared, you can't just call this x squared plus h squared. If you do that, you're going to miss it. You need to come to the side over here, and we need to FOIL x plus h squared. So y'all, let me give y'all this advice. Write this down, what I get for x plus h squared, because everybody's going to have to FOIL that x plus h squared on this one. So the answer I get will be the answer y'all get on y'all's. And it's the answer I'm going to use every time I got an x plus h squared, okay? So come down and we're going to write this twice, and we're going to FOIL it. Once we get that answer, we'll plug it in over here. So x times x is x squared. X times h, I'm going to keep mine in alphabetical order and call that a hx. And I do that because it's easier to keep up with your like terms if you sort of keep them in alphabetical order. All right, this h times x gives me a h times x. And y'all, that h times h gives us a h squared. So now let's add the like terms. X squared. And y'all, these are both positive, so they don't cancel. You treat this like a 1 plus 1, which gives us 2 hx plus my h squared at the end. Save this for when y'all do this problem, okay? Anytime you get an x plus h squared, replace it with this. So y'all, let me put that over here. I got x squared plus 2hx plus h squared. And then at the end, I got a plus 3. And y'all, guess what? Are there any like terms here?
No.
No.
No, so that whole thing is now f of x plus h. So we're going to plug them in. X squared plus 2hx plus h squared plus 3. That's my f of x plus h minus my f of x, which is x squared plus 3, all over my h. All right, y'all, let me let one in real quick. Keeper. All right, so same thing. We're going to drop parentheses and distribute our negatives. So that brings this out as an x squared plus 2hx plus h squared plus 3. All right, negative times positive gives me a negative x squared. Negative times positive gives me a negative 3 all over my h. All right, y'all. So time to combine like terms on top. Are there any like terms?
X squared and positive x squared, negative x squared.
All right, so those are like, and they're going to cancel again.
And then positive 3 and negative 3.
Positive 3, negative 3. So y'all, let me ask you this. Are y'all noticing that the second parentheses is canceling out every single time?
No.
Well, they are. Everything that I've had in the second parentheses has canceled with the first parentheses. Let me turn my page over to what we did a while ago. Right here, the second parentheses was 7x and 3. Guess what? They both canceled out. Down here, we had 6x and 10. Guess what? They both canceled out.
Is that because it's the original f of x?
Well, and it's because every time you do this, at this point, the only terms left are the h terms. And see, these don't even have h's in them, so they're going to cancel out every time because f of x plus h will always cancel the terms from the second parentheses. So every single time, these are going to cancel, okay? So what's left on top? Ooh, I got two terms on top this time. I got a 2hx. I got a plus h squared all over h. So y'all, my question is, what is my final answer going to be?
That's the answer.
Oh, can you not simplify this?
Oh, because what do we put an invisible 1 in front of the h at the bottom?
Well, what you got to treat this like is that both of these on top are both being divided by that h. So what happens to these h's right here?
Oh, they all cancel out, and you're just left with an x squared, 2x squared, right?
Or just a 2x.
Oh, okay.
Because remember, you're not changing the x's. All you're doing is canceling out the h's on that one. Now, the h also applies to the h squared term. So what happens when you got an h squared divided by just the h?
It becomes a h.
It
What do
stopped
y'all
there.
call it? Okay, okay.
Because see, remember, these got exponents on them. And if you don't have an exponent, it's a 1. So here, 1 minus 1 is 0, so the h's are gone. Here, 2 minus 1 is 1, so you got the 1h. And y'all can't go no further, so final answer. So y'all, when you got fractions like this, it's really this going on. 2h x over h plus h squared over h. Every single term on top gets divided by these denominators, okay? So we canceled the h's on this one and got the 2x left. Here, we subtracted exponents. 2 minus 1 left me with 1h, okay? So you got to remember, if I had 3 things up here, I'd put them all over that h, okay?
I think somebody said they got a question, Mr. Eugene.
Okay, I'm hearing it.
Yeah, I have a question. So with the H's, I understand it, I think. I just want to double check because like technically the top H squared would be like to say H times H.
Yeah.
Like if you actually wrote it out. So then you would have that one left over on the top.
Yeah, because one's canceling and one's left.
Okay.
Because remember, that's what that exponent's telling me. How many
Yep.
times are them h's being multiplied, right? So good job.
Okay.
Exactly. That's it, okay? And let me turn this over. Flipping up again. All righty. So you see they're getting more interesting. All righty. So watch this one. Woo, this one's a good one. F of x equals, let's see what I got here. Negative 2x squared plus 3x plus 5. And we're still going to construct our f of x plus h minus f of x all over our h. So y'all look at this one. This one got 2 x's. So guess what? We're going to put an x plus h in for this one and an x plus h in for that one. So let's find our x plus h.
Can
So
you
we're
please
going to have,
move your cursor again?
say again.
Can you please move that cursor?
Oh, my cursor's on the way. Okay, there we go.
Thank you.
All right, so y'all, let's put our x plus h in. We got -2 times x plus h squared plus 3 times x plus h plus 5. So it still looks like the f of x, except our x's are a lot bigger now. So bring down that -2 because remember, you got to FOIL this first. But y'all, we know what x plus h squared equals, don't we?
Yeah,
FOILed
it's on the other sheet, but
yeah,
yeah.
we FOILed that won't go. So remember, that was the x squared.
X squared plus 2hx plus h squared.
There you go. And then I'm bringing everything down, okay? I'm just going to bring everything down. I'll do all my distributing and stuff on the next step. So all I did that step was just that I squared that and got this. Now we got to distribute the -2 through the first parentheses and the 3 through the second parentheses. So y'all, -2 times x squared is a -2x squared. -2 times 2hx is what, a -4hx. -2 times h squared is a -2h squared. Now distributing the 3, we get 3 times x is a 3x. 3 times h is a 3h. And then at the end, we bring down our plus 5. So I distributed my 2, I distributed my 3, and then I brought down the 5. So y'all, here's what's sad. Are there any like terms that I can add together?
You said how many or you need?
Well, do I got any like terms in here? Because I don't have but one x
No.
squared.
No.
No, because that's hx, h squared, x, h, number. Nothing's like terms. So this whole thing is now going to go in for our f of x plus h in our formula. -2x squared minus 4hx minus 2h squared. Ooh, that thing's got 1, 2, 3, 4, 5, 6 terms. Plus 3x plus 3h plus 5 minus f of x, which is the -2x squared plus 3x plus 5. And y'all guess what? All of that over h. So sometimes they're long, depending on how many x's are in these functions up here. That expanded this thing out pretty good here. So now we're going to drop parentheses and distribute our subtraction to all 3 of those in the second parentheses.
So then those 3 will all cancel out.
They're
'Cause
going
it's
to
all
in a
gonna be
second, ain't they?
opposite signs.
Yeah, they're about to all cancel out in a second, other than this h,
Yeah.
this h, and that h. So
Yep.
see, now you're catching on. So there you go, -2x squared minus 4hx minus 2h squared plus 3x plus 3h plus 5. And then look here, positive 2x squared, -3x, and then a negative times positive makes that a -5. All of that over h. All right, so you told me this 2 is positive 2 is going to cancel with that -2x squared.
Yep. And then the -3 and the
Uh-huh.
positive 3x.
Uh-huh.
And then the 5 and -5.
Bam, bam, bam.
And that's just gonna be negative 4hx
Okay, so let me, so negative 4hx, keep me going.
minus 2h squared
Uh-huh.
plus 3h over h. And then you'll cancel out the h's.
So canceling out h's, what's going to be my final answer?
It'll be
Negative 4x minus
negative 2h plus 3.
Y'all doing good. Everybody got divided by the h, and that is my final answer. So y'all, when you get really good at these, you're going to be able to come in here. Once you got this f of x plus h right here, I could have just canceled everything that didn't have an h in it, put that over to h and been done, right?
Yeah, because that's what I noticed when you wrote it all out. Because that negative is going to turn
Yeah.
everything opposite.
Exactly.
You
So
just
if you get lazy,
cancel
you can
right
just
up
say,
there.
okay, I got this. I'm going to cancel out the stuff that ain't got an H, and then I'm going to put that over my H and simplify, okay?
Yeah.
Just keep up with your signs is the main thing on this stuff that does have the H's.
Mm-hmm.
All right, so, okay, they were, well, you think they're being nice with this last one I got? I got a 5x to the third. So we think they're being nice because that's pretty short looking compared to this long one. Remember, I had negative 2x squared, 3x, and a 5. This is just a 5x to the third. And we're going to do our formula for the last. Then this is, this will be like the last one. Minus f of x, and all that's going to be over h. But y'all, guess what? F of x plus h is going to be 5 times x plus h to the third. I don't know what that is yet because we did it for the squares, but we didn't do it for the cubes yet. So you would have to come to the side again. And we need to figure out what x plus h to the third is going to equal. Well, y'all, x plus h times x plus h times x plus h. We got to write this one 3 times. So we got to FOIL 2 of these. Once we get that answer, we FOIL times the first one. But y'all, guess what? I'm going to bring down that x plus h in the front.
So could you just do the squared right away and then just add another xh?
Exactly. Because guess what? What did these two FOIL into?
Well, I can't remember the one, but yeah, it's like the 2h or
It was
2x.
X squared plus 2hx plus h squared.
There you go.
Yeah.
So since we knew what 2 of them were, let's just bring that on down, and now we're going to multiply
It
the
would
x.
be x to the third
Okay, so keep me going. X to the third.
plus, is it 3h?
Well, remember, you got an x times the 2h.
Oh, wait.
Is it 3
Or 4h.
Or
Well, the 2h will
3h.
stay the same. The 2h part will stay the same, but the x times x will give me what? An x squared.
To the third or squared. Okay.
All
All right.
remember, I only had one x, multiplied by one x, made that x squared. And then here, x times h squared is just a x h squared.
Hmm.
How did you get the x squared at the end of the 2h?
Well, because I had an x times a 2hx. See, I had this x times 2hx, right? Well, the 2
Oh,
can't
okay.
change because there's nothing to multiply 2 by, so the 2 comes down. The h can't change because there's no more h's to multiply.
And then
But you
just
got
do
the x times x, which is
x
x
squared?
squared.
x squared. Okay.
Okay.
Now this one you're distributing a h. So the only thing that can change are the h's when I multiply. This h times x squared is just a x h squared. I mean, my bad. I went the wrong way. It's a h x squared. I said it, but I wrote it wrong, okay? H times x squared is a h x squared. How about a h times a 2hx? Y'all, let me write this out further because I'm getting too squunched up.
You said H.
Oh, you said h times the 2x. H is going to be 2x squared x, I think.
2h squared x. Good job. Basically, all we're doing is adding the h to everybody. And then how about that h times that h squared?
Is there going to be h cubed?
H cubed. That's it. Now you will find some like terms over here. I got a hx squared. It'll add to a hx squared. And then I got a xh squared. Whoops. I should have put this one in alphabetical order because that's really a h squared x. That's where I was messing up. I like them in alphabetical order because this h squared x here will add to this h squared x. So I'm going to bring down the x to the third. 2hx squared plus 1hx squared gives you 3hx squared. 1h squared x added to 2h squared x's. So these are now like terms. Gives us 3h squared x. And then what's left at the end? Where'd it go? To the h to the third. So save that for when y'all got to do a cube, okay?
Say which part?
Huh? Oh, save this for when you have x plus h to the third.
Okay.
Because y'all's
that
number
Oh, we
five.
never have to do that every single time.
Yeah, you don't want to pull this out every time. So
No,
just
I
save
don't.
this.
Not at all.
So that is a H squared X.
So I got x cubed, 3hx squared plus 3h squared x plus my h to the third. So y'all, I'm putting that right here now. X cubed plus 3hx squared plus 3h squared x plus my h to the third. So now one more step is to distribute 5 times everything. So let's see what we get when we distribute that 5. Now we can only change the numbers. We can't change the exponents or the variables. So 5 times 1 gives you 5x to the third. All right, y'all keep me going.
15
15x hx.
All right.
squared. And then plus another 15.
And that's what h squared x is.
And then plus 5h3.
5h3. And at this point, there's no more like terms because we added the like terms over here to get this stuff. All we did here was multiply by 5. So no like terms. So all of this is f of x plus h. So let me plug that into my parentheses. 5x to the third plus 15hx squared plus 15h squared x plus 5h to the third minus, and y'all were sad this time because the only thing for f of x is the 5x to the third. But we knew this stuff wasn't canceling because each one of these has a
Variable.
variable h in it.
But wouldn't the 5x to the third cancel?
Oh, they're about to cancel. Good job. Now this one, you can rewrite all this if you want to, distributing that negative. But since that's the only thing here, you can pretty much cancel that thing right out if you wanted to.
And then just bring the 15hx squared down.
Uh-huh.
But can we cancel the h's right now also?
So I'm gonna cancel that. Now, if you wanted to, couldn't you?
Yeah,
that's
so I could
what-
just do 15x squared and just take
because
that
those h's cancel, so 15x squared.
plus
All right, y'all, what's
15
next?
squared
X plus 15 squared X.
plus 15 cubed.
Oh, hold on now. What are y'all getting right here?
Oh, no, I'm sorry. No, plus
It's the
15H.
15H squared X.
It's 15H. Yeah. X, because
15h
because it just takes away one
Squared.
H by both of them.
and an x.
Yeah.
Yeah, so I
Oh,
took
wait,
one-
wait. What happened to the?
Yep.
Hold on. I'm confused.
All right, so let me show
Say
y'all
what
what.
The
So
square.
y'all, y'all watch
You
this.
lost.
Watch what I'm going to write it out in. Show you what everybody's getting divided by that h. Member. And then at the end is what 5h cubed over h. So the first one, when you did the first one, you did good. You canceled out the h's. 15x squared was left. The second one,
Oh,
remember the second one, you had two h's on top. So that's like an h times the h. One of those h's canceled with the bottom, leaving me with a 15h x, because I still got that x up there, remember? What's happening
Okay.
here?
the H will cancel, so it'll be just 5 to the third.
Yep,
Well, I got a
5
third here. If you cancel one of them thirds,
Oh,
five
so
squared.
5H squared.
squared.
yeah, because see, you had three h's, you canceled only one, that's going to leave two. So that's going to leave me what, an h squared. So when you divide by h, everybody goes down by one h. This one, when I went down by one, it was gone. I had two, went down by one, left me one. Had three, went down by one, left me two. Y'all want to try one more of those?
Yeah,
Oh,
'cause-
yeah.
yeah.
That long of one? Not really.
Oh, come on, y'all got to get these cubes.
That's the kind I want them. That's the
Yeah,
kind I want them to do. Another one of them.
Because I need to learn how to do this.
So f of x, and I'm going to make this one positive. How about lucky 7x to the third? So f of x plus h minus f of x all over h. So y'all, we're going to find f of x plus h, which will be 7 times x plus h cubed. So I'm bringing down my 7. We know what x plus h cubed is, right?
Yeah.
It is x cubed plus 3hx squared plus 3h squared x plus h cubed.
There you go.
Yeah.
So not too bad since we know what this equals now. Now, let's just distribute our 7 through here.
So
7.
would that be 7x cubed plus 21h x squared plus 21h x plus 7h.
Oh, that was an h. That was an h squared x. My bad. Make that an h squared x. Y'all told me it was a square, and I didn't even write the 2. My bad. That is a h squared x there. Okay.
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 Yeah. Okay.
And then plus
7h cubed.
7h cubed. All right. Can't do nothing else with that. So let's plug that in. 7x to the third. 21hx squared. 21h squared x. And then what? 7h to the third. Minus only my 7x to the third. All of that over h. So y'all, let me distribute it because I think I was losing some doing it all in one. So I'm just going to distribute it and make this thing a negative.
Negative 7x cubed.
Ooh, there's a lot of writing on this one, ain't
Yeah, the problem looks like it's going to be small, but it's not.
it? That's what I'm saying. Don't let that little 7x cube fool you. Because of that cube, it made this thing unbearable almost.
Triple, yeah.
But guess what? I did all that so I can cancel that with that. All right, so y'all have 21hx squared plus 21h squared x plus 7h to the third all over h. So y'all,
Start canceling H's.
yeah, give me my final answer.
21x squared plus 21 squared
No,
plus
21H.
7.
21h.
21H.
Oh yeah, H. Yeah.
Oh, give me a little more.
Um.
21h.
21HX.
Oh yeah, the X. I
Yeah.
forgot the X is at the end. And then the 7H squared.
Yeah.
That's it, y'all. Everybody got divided by that h, and we're happy now, okay? They're not too
Okay, that
bad.
made it easy. Yep, that made it seem like it's pretty easy.
But if y'all get to take business calculus or calculus, you'll see this again in life. So anybody that's doing maybe engineering, technical stuff, you might see this again, okay?
Glad that's not me.
So nurses and respiratory people and psychologists, you probably won't have to see it again, so y'all are more sad.
Mm-hmm.
Right. Sad is the word.
Devastated.
Y'all,
Yeah,
guess
but
what?
you do a whole different type of other math in nursing though.
Oh yeah. Well, and then they'll get y'all a lot. Y'all going to play with fractions a lot when y'all do your dose rates and all that kind of fun stuff.
I know, I'm not looking forward to it.
And y'all get to do statistics if you do the BSN route.
Yeah.
Oh my God, I ain't looking forward to that either.
Y'all quit hating on the math. So y'all, that is everything for test 2. I've got the study guide open for test 2 if you want to play with it before Monday. But Monday night, that's all we got. We're going to review for test 2, and it'll open on Monday, and it'll be due the next Sunday, which will be is it the 15th, I think.
The next Monday's the 16th.
Yeah. So, but it'll be due that 15th on the Sunday night, okay?
Oh yeah.
And
So
next Monday
I'm opening it on the 8th, and it'll be due.
A
Yeah.
week from then.
on the 15th. But Monday you're doing the review, right? For the
Oh yeah, I'm going to do the Monday review. So if you want to wait on the review before you even attempt that test, I would do that too.
Yeah.
Okay.
For sure. Are you gonna do it just like you did the last test where you kind of went question by question?
Yeah.
Okay. Then yeah, I'll wait.
Yeah. It's like 20 questions again. So,
Okay.
but remember, it's got your favorite wire one on there and your other favorite one, the ladder. It'll have some of these on it, and so yeah, it goes all the way back to where we did the remember when I did the symmetry to the y-axis and all that fun stuff?
Is that 4.8 or something?
Oh, 4.8 will be the 2-word problems you'll see.
Yeah. Okay.
Mm-hmm.
I got a quick question for you, Mr. Raffon.
Yeah, I hear
The
you.
5.4, the section 5.4 complex rational expressions
Uh-huh.
homework. Where can I find, is that on the last